Okay, let's dive in. So maybe you saw this floating around online recently, a video from China's Tiangong space station.
Oh, yeah, I saw that one.
Right. And it shows an astronaut, doing their thing. But the bit that everyone kind of fixated on wasn't the astronaut at all.
No, it was that glass of water.
Exactly. Just a normal open glass of water sitting on a table,
Mm.
perfectly still, no lid, nothing special.
And the reaction was pretty immediate, wasn't it? Especially on places like X.
Totally explosive. The big question everyone was asking was just, why isn't the water floating out? Like everywhere.
It's fascinating, really, because it taps into this visual expectation we have about space. Weightlessness means things float, period.
Right.
So seeing water just sitting there calmly, it just short-circuited a lot of people's understanding. The comments were full of disbelief. How is this possible? Isn't space zero gravity? That kind of thing.
It really didn't compute for folks.
Yeah.
I remember seeing one comment on X. The person was basically saying, look, call me crazy, but orbiting Earth at 17,500 miles per hour, 0G, valuable computers everywhere.
Uh-huh.
I probably wouldn't risk having an open glass of water just chilling on a table.
Yeah.
The assumption was it has to float out.
And that assumption, while totally understandable from our Earth-based perspective, really gets to the heart of a common misunderstanding about, well, how liquids actually behave up there.
Yeah, and it snowballed fast, didn't it? From simple confusion to full-blown conspiracy theories. Was the footage faked? Are they even in space?
Exactly. It became this whole viral moment based on that one seemingly impossible detail.
Which is why we figured, okay, this needs a proper deep dive. We want to unpack the actual science behind why that water isn't floating out.
It's not just about debunking, though. It's about uncovering some really cool physics that's always happening in space, but sometimes looks completely alien to us.
Absolutely. Because the core issue here is that intuitive clash, right?
Right. What you see stay water feels completely wrong based on what you expect to see in space.
We've all seen those, amazing videos from the ISS, astronauts squeezing water, and it forms these perfect floating spheres.
The globular blobs, yeah, they just hang there in the air. It's mesmerizing.
So your brain immediately goes, okay, that's space water. Why does the Tiangong water look like Earth water? What's keeping it in the glass?
It's like our brains are just wired for gravity. Anything else looks like a special effect.
And yeah, we talk about zero gravity, but technically it's microgravity, right? There's still a tiny bit of pull.
There is, but it's not really the main player here in terms of keeping the water in the glass. The lack of strong gravity is what allows other forces to dominate.
Okay, so if it's not gravity or lack thereof, what is holding that water back? That was the question fueling the whole conspiracy, wasn't it? Why isn't it floating out? It just looks so wrong.
And that's where the real science comes in, the stuff that's usually invisible to us down here. It boils down to two key things: surface tension and adhesion. There's a space historian, Jordan Bim, at the University of Chicago. He put it really well. He said something like, water molecules like to stick to glass and also to other water molecules more than they like to disperse in the air.
So it's the water itself and the glass.
Yeah.
How does that work on a tiny molecule?
Exactly. Think of water molecules, H2O, right? They're a bit like tiny magnets. The oxygen part is slightly negative. The hydrogen parts are slightly positive.
Okay.
So they attract each other quite strongly. They pull inwards towards the other water molecules. This creates a kind of invisible skin on the surface. That's surface tension.
Ah, right. Like how insects can walk on water sometimes.
Precisely. That same force. In space, without strong gravity pulling the water down and out, that internal pulling together force, the surface tension, is really dominant. It helps the water stay, well, intact, as Bim puts it. It wants to hold itself together.
So it's like the water is creating its own container almost. A liquid force field made of sticky molecules.
That's a great way to think about it. And Bim also points out that if there is no external force, water remains in clumps. In this case, the clump is just conveniently inside the glass.
Okay, so that's surface tension, water sticking to water. What was the other one? Adhesion.
Right, adhesion. That's the water molecules sticking to other things. In this case, the glass.
Like condensation on a cold glass.
Exactly like that. Water molecules are attracted to the molecules of the glass surface. So you've got surface tension holding the water blob together and adhesion helping it cling to the inside walls of the glass.
Wow.
Together, these two forces are strong enough in microgravity to keep the water neatly inside that open glass. Bim says surface tension works to help maintain the static shape and presents the illusion of how water would act on the ground.
An illusion. But it's real physics.
It's totally real physics. It looks bizarre to us, maybe counterintuitive, but it's exactly what physics predicts for that situation. It's actually a beautiful demonstration.
That really is the aha moment then. What looks fake is actually textbook physics, just,
Yeah.
without gravity getting in the way.
Precisely.
And this wasn't just a theory they talked about, right?
Right.
Didn't the Tiangong astronauts actually show this stuff happening?
They did, which was brilliant. They have these live educational broadcasts at Tiangong classes.
Yeah.
And during one, they did this fantastic little experiment. They took that same glass of water and they put a ping pong ball in it.
Okay, and what happened? Here, it'll pop right up to the top.
Exactly. Buoyancy. But up there in the space station, the ping pong ball just stayed put, suspended right there in the middle of the water, didn't float up, didn't sink, just hovered.
Whoa.
Which, as they pointed out, was further proof that the physics match what you would expect to happen in space rather than on Earth. Clear visual evidence, no tricks.
Okay, so the water stays put because of surface tension and adhesion. Got it.
Got it.
But what about the glass itself? That comment I mentioned earlier about the risk.
Yeah.
Why wasn't the glass floating around? Surely that could damage stuff.
That's a fair point, and a very practical one for working in space. And they addressed that too.
Oh, they did? Yeah.
Yeah, China's space agency put out a sort of behind-the-scenes video on Weibo, their social media platform. It showed astronaut Wang Yoping doing the demo.
Uh-huh.
And you see her first pouring water into the glass using a straw, which is actually a pretty common technique for controlling liquids up there.
Makes sense. Less splashy.
Right, and then here's the key part. She secures the glass to the table with simple adhesive strips, like tape, basically.
Ah, so the glass was stuck down.
It was tethered, yeah, just like you'd secure any tool or object you don't want floating off randomly.
Right.
So the water physics is real, and the glass staying put is just good, practical space housekeeping.
That makes perfect sense.
Mm.
Clever, really. Let the physics handle the water, use tape for the glass.
Mm.
And I guess that also explains why we usually see astronauts drinking from those sealed pouches with straws, right?
Oh.
Even if an open glass can't work, it's probably just way less hassle to use a pouch.
Yeah. Absolutely. It's much more practical for just grabbing a drink.
Mm.
Samantha Cristoforetti, the ESA astronaut, she's shown how tricky it can be to actually get water out of an open container in microgravity without making a mess. It wants to stick everywhere.
Right.
So pouches are just easier day to day. And, stepping back for a second, it's worth remembering Tiangong isn't some theoretical thing. Its existence, its experiments, they're verified by international observers. Even the U.S., China's biggest competitor in space, cracks it.
Good point.
China has a seriously sophisticated space program. Look at the recent Cheney 6 mission landing on the far side of the moon and bringing back samples. That's incredibly complex. It adds to the credibility of what they show us from orbit.
So this whole thing, the viral video, the confusion, the science,
Yeah.
it really does become a great teaching moment, doesn't it?
It really does.
It shows how science can sometimes feel completely wrong based on our everyday intuition. Our Earth sense just doesn't always apply off-world.
Absolutely. And it also shines a light on how misinformation can catch fire, especially online. Something looks weird, it seems to defy common sense, and boom, it spreads.
Yeah.
Even AI chatbots, apparently, like Elon Musk's Grok. It reportedly repeated the incorrect idea that the water should float out, so it got caught up in the misinformation swirl.
Wow. So it really underlines how important critical thinking is and maybe double-checking things, especially when something online just feels off or confirms a conspiracy vibe.
Definitely. You have to ask, okay, it looks strange, but is there a scientific reason? In this case, yes. What looks strange at first glance is actually a clear demonstration of how surface tension works in space. It wasn't a cover-up, it was physics class.
Physics class in plain sight.
Exactly. And, space stuff seems particularly prone to this kind of thing. It's not new.
No.
No, there's a long history of space-related conspiracy theories. The Apollo moon landings are the classic example, of course. But other things, too. Alleged secret missions, weird lights.
Huh. So the water glass is just the latest chapter.
Pretty much. It shows that skepticism is healthy, but it needs to be paired with actually looking into the science, especially when you're dealing with an environment as weird and wonderful as space.
Okay, so wrapping up this deep dive then. That glass of water sitting still on the table in the Tiangong space station. Not a hoax, not faked.
Not at all.
It's a real-world demo of surface tension and adhesion doing their thing in microgravity. Physics 101, essentially, just without the gravity complicating things.
And validated by the astronauts' own experiments, like the ping pong ball, and backed up by decades of understanding fluid dynamics in space.
What really strikes me is how easily our Earth-based intuition can lead us astray. We see something that doesn't fit our normal and we jump to conclusions.
It's true. Our whole experience is dominated by gravity. Take that away. And other forces, like surface tension, suddenly take the lead role. What seems inconsistent is actually just different physics taking center stage.
It's a fantastic reminder that the universe operates on rules that can seem really strange, but are often beautifully simple once you dig into them.
Well said.
And that, listeners, is what makes a deep dive like this so rewarding, right? Sometimes the most unbelievable sights in space are just physics, being physics, plain and simple. And sometimes the most ordinary things hide incredible science. It really makes you wonder, doesn't it? What else do we just accept or take for granted down here that has some totally unexpected science behind it, just waiting for us to notice?
Good question to ponder.
Well, if you enjoyed figuring out this bit of space science with us, please do give this deep dive a like and subscribe to the deep dive so you don't miss our next exploration. Check out the affiliate links in the description if you'd like to support the show. It really helps. And definitely let us know in the comments what other baffling, weird, or wonderful topics you think deserve their own deep dive.
Yeah, we love getting suggestions.
Absolutely. Until next time, keep asking those questions and stay curious.